Right, today we're going to look at the recursive formula. So back in integrated 1, you learned something called now next equations. And that was actually just an introduction to what is the recursive formula. So let's refresh our memory first on the now next equation. So now is always talking about your y value when your x is 0. So here's x is 0 and our y value is 2. So our now is 2. Next, so we're starting at 2, we're going to 5, then 8, then 11. So we are adding 3 every time. So our next value is going to be our now value plus 3. So that's how we wrote a now next equation. So to do the recursive formula, we have these 3 things to look at. So it's basically the same thing. The notation is just a little different. So this stands for a sub 0. So a sub 0 is going to be our initial term. A sub n, this is going to be our next term. I kind of remember that n is next, and then a sub n minus 1. So if we take this term and subtract 1 from it, well, that's just our previous term. So a sub n minus 1 is our previous term. So if we actually want to write our recursive formula, a sub 0, so this was our initial term. So our initial term up in this table, it's the same as when your x is 0, so it's going to be 2. And our a sub n, so now instead of saying now plus 3, we just write a sub n minus 1, which means previous term. Oops, previous term, and then plus 3. So this is how you write a recursive formula. Okay, then we can also write an equation for this. So when we write an equation, we know it's going to be linear because it has a y-intercept, and then you're adding something to it every time. So just a refresher, b is your y-intercept, m is your slope, or m is the number that you're adding every time. So to actually go ahead and write that, hang on, let me move my camera quick. So y equals m, which is our slope, or what we're adding every time. So that was 3. And you have x plus your y-intercept, or your starting value, which was 2. So y equals 3x plus 2. This a sub 0 equals 2, a sub n equals a sub n minus 1 plus 3. And this now next equation, all 3 of these things are representing the exact same thing. Okay, so let's look at another example. Okay, so let's write a now next first. So now next, now, so you go to where x is 0. So here's x is 0. Our now is 100. Next, so it looks like we're going from 100, 80, 60. So it looks like we are going down by 20 every time. So our next is now minus 20. To write the recursive formula, a sub 0 was initial, so our initial value is 100. And then a sub n, so we can take a sub n minus 1. This just means your previous term, so a sub n minus 1, and then we are subtracting 20 from it. And then to write the equation, it's linear, so we'll have y equals, so it's mx plus b. m is your slope, or the number you're adding or subtracting every time. So negative 20x, and then plus your initial, which was 100. So all 3 of these, now next, recursive equation, are all representing the exact same thing. Okay, so let's look at one that's a little bit different. All right, so let's start with a now next. So now looks like 1. Our next value, so we're going from 1, 3, 9 to 27. So we're actually multiplying by 3. So we are going to do next equals now times 3. You cannot just put times 3 because I don't know what you're talking about. Am I taking the previous term times 3? Am I taking the next term times 3? So you have to make sure you put now times 3, or you can write 3 times now. I don't have a preference. So when we write our recursive formula, a sub 0 is our initial. which is 1. A sub n is our next value. So we have a sub n minus 1. Okay, so now you have to put the 3 out in front. So 3 times a sub n minus 1. You can't put it at the end. And for our equation, this time it's not going to be linear because we're multiplying, not adding every time. So here's our exponential equation. So you have y equals a times b to the power of x. And just a reminder, a is your start value, and then b is what you're multiplying by every time. So to write this equation, we'll have y equals a, which was our start value, so 1. And then in parentheses is our b value, so what you multiply by every time, which is 3, and to the power of x. Okay, and then one more. Okay, so now next we have now equals 24. Next equals now. So we're going from 12, 24, 6, 3, 1.5. So it looks like we're dividing by 2. So here's the deal. You cannot do any division in now next recursive or in an equation. So instead of dividing by 2, get rid of that, we're actually multiplying by 1/2. So our next is now times 1/2 or 1/2, get rid of that, times now. Our recursive formula, we have a sub 0 is our initial. So our initial is 24. Okay, so I'm going to show you something a little different here. What if I want this to be a sub n minus 1 first? So technically you can write anything you want out here. You can write an a sub n plus or minus whatever you want. But whatever goes right here has to be the term right before this. So if this is a sub n minus 1, what's the term right before this? Well, that's going to be a sub n minus 2. So this would be, now this would be our previous term, and this would be our next term. It's a little confusing, but you do see this written other places, so I just wanted to show you that. And then we're multiplying by 1/2, so that goes out front, and I wrote that really stupid, so hold on. A sub n minus 1 equals 1/2 a sub n minus 2. So that could be a recursive formula. Or you could just write a sub n and then 1/2 a sub n minus 1. And then to write the equation, y equals, and then a, which is our initial, which was 24, b, which is what you're multiplying by, which is 1/2, to the power of x.